So we are talking about molarity, and this is the molarity worksheet walkthrough from your notes. Let me just take a peek and see what page this is in your notes. I should have had this open and ready to go, shouldn't I? Okay, way to be prepared. All right, this is page number 54 in your notes. All right, so page number 54 in your notes book, everyone. You're going to need your reference tables because we have our formula for molarity on your reference tables. And we're also going to need your periodic table because we're going to be reviewing some mole calculations, and we're going to have to calculate gram formula mass because we're going to need to calculate the moles, right? So that's going to connect us back to one of our previous units where we talked about moles. So now just to review, molarity is moles of the solute, right? So that's what we're trying to dissolve, the smaller amount, dissolved in liters of solution. So we have to make sure if we're calculating molarity, which is capital letter M, right? Capital letter M for molarity, we need to make sure that we have our volume of our solution, liters and not milliliters, and we need to make sure that we have moles and not grams. And so just again, remember mole of one substance. So 1 mole of any substance is equal to the gram formula mass, which is you take the masses of the elements and you add them all up. And formula from your reference tables, right? The moles is equal to given grams divided by that gram formula mass, right? Which here we have grams over gram formula mass, right? Those two work together. All right, let's get started. Our first question says, what is the molarity, right? So what is the molarity? Question's asking me for capital letter M, where we have 58 grams of sodium chloride dissolved in 1 liter of solution. So now here I have grams, but my formula has moles. So I need to first convert 58 grams to moles. So I am going to write down my number, 58 grams and 50 grams of sodium chloride. Now I need to convert this to moles. And so now I need to know the gram formula mass because 1 mole of any substance is equal to its gram formula mass, right? Or I take this grams and divide it by the gram formula mass from table T. So now, according to my periodic table, the mass of sodium, let me go over here. Where's my rotate view? I don't know where my rotate is at the moment, so I'm not going to bother. You can look at it sideways. I'm sure you can deal with it. Right, here's our gram formula mass, right? We have sodium with its mass of 23. And we have chlorine over here with a mass of 35. So I have my 23 plus my 35, and that is equal to what again? Let's do it on our calculator just to make sure, right? So 23 plus 35 is equal to 58. That means that 1 mole of sodium chloride has a mass of 58 grams. So I'm going to get rid of grams, and I want to go over to moles, right? Grams per mole, right? Grams per mole. So then 1 mole is 58 grams, right? And so grams divided by gram formula mass, 58 divided by 58. So this is 1 mole. You probably could have recognized that and not have to do the math, but that's okay. I'm taking through stepwise. Second step, now that I have moles, now I can figure out the molarity because that's what my question is asking. Capital letter M, molarity, is equal to the moles divided by liters. So I have 1 mole of sodium chloride divided by 1 liter of solution. And so now my molarity is equal to 1 divided by 1 is 1. And what is my units? 1 mole per liter, 1 M, right? 1 capital letter M, that's 1 molar solution of sodium chloride. All right, so now let's go through, and now what is the molarity of a solution where we have 10 grams of silver nitrate dissolved in 500 milliliters of solution? first of all, I need to convert my grams to moles because I need moles. Now I have milliliters, but again, I need liters of solution. So I need to convert my milliliters to liters. All right, so let's do milliliters to liters. I have 500 milliliters. Milli is 10 to the minus 3 on your reference tables. So then I am going to go from milliliters to liters. 1 liter, the larger unit, always gets a 1. And then is 1,000, right? Because that's what 10 to the minus 3 is 1,000 little milliliters in 1 big liter. So then 500 divided by 1,000 means I move this decimal place 3 places to the left. So then that is going to be 0.500 liters. Now let's take care of our grams to moles conversion. I have 10 grams, and now I need to convert that to moles. And now I need to go from grams to moles. So I need the gram formula mass of silver nitrate. So oxygen has a mass of 16. I have 3 of those. Nitrogen has a mass of 14. So I have 1 of those. Silver, I don't know off the top of my head. Let's take a peek at the silver at that's 108. So I have 108. So now I'm going to multiply my 16 times 3, doing on my calculator, and then I'm going to add that 14 plus that 108, 170. So that means that 1 mole of silver nitrate has a mass of 170 grams. So now I do 10 divided by 170, right, to get my moles, and that's 0.05. And how many sig figs do I need? I need to have 3 sig figs, 8 moles. How do I know that I needed 3 sig figs, right? Decimal point present, 3. Decimal point present, 3. If you're in Regions Chem, we might not be using the significant figures. That's okay, but I want to make sure that I'm including them anyway. It's a good review. So now I'm going to calculate my molarity. Capital letter M is equal to the moles of our solute. So that was our 0.0588 moles divided by our 0.500 liters of solution. So then my molarity is equal to, let me divide by my 0.5, is 0.118 molar, right? Or 0.118 moles per liter, right? Because that's what we did. We took moles, we divided by liters. All right, let's move into our next one. Now I want to know how many grams of potassium nitrate should be used to prepare 2 liters of a 5 molar solution. Wow, okay. So my question statement is asking about grams. And so now if we looked at our first 2 problems, right, we used 2 formulas, right? We used our moles, we used our molarity. And now we're still using the same 2 things. We're still using moles and molarity, but in this case, we're not starting with grams. So we're not starting by converting to moles. We're going to finish converting to moles. So first, we're going to use our molarity formula, all right? And because that's what I have the most numbers for, right? I have my liters, and I have that capital letter M, right? Because that stands for molarity. So let's take care of that first, right? So molarity is equal to moles over liters. So I'll just do moles over liters. And so now what do I have? I have my molarity is here, right? 0.500. So I have 0.500 molarity. And then I don't know, that's what I'm looking for, right? I need to find those moles because that's how I'm going to get back to grams. And now I have the liters of solution, right? And it's in liters, that's good. So then I have my 2.00. So then I multiply, right? 0.5 times that 2. Which I should be able to do in my head, right? So that's going to be equal to 1, right? So this is equal to 1, and then I'm keeping sig figs as 3. So that means I have 1 mole, Okay, now all I need to do is I need to take this moles and I need to convert that over to grams. So now I have 1 mole. I already know that 1 mole is equal to the gram formula mass. So all I need to do is calculate the gram formula mass here and I'm all set. So I have potassium, which I believe has a mass of 39, fact checking myself. Yes, I'm correct. All right, so I have a 39, nitrogen with a mass of 14, and I have 3 oxygens, each with a mass of 16. So when I do my math, I have 39. Oh, let's just do my 16 times 3. That's 48. And then I'm going to add that 14, add that 39, and now I have a mass of 101. All right, so that means I have 101 grams. And do I have 3 sig figs? Yes. Cool, 101 grams is my final answer. All right, let's go on to our next one. Okay, wow, so this sheet is asking us to do all kinds of stuff with these 2 formulas, right? So now I need to know what volume is. Okay, so volume is measured in liters. So that means that's what my final step is going to be. And then I'm going to use that liters, the denominator of that molarity equals moles over liters formula. So now I have grams, always going to have to make grams to moles, right? Because now I have that molarity solution right here, right? So let's just write down, here's my formula. Molarity is equal to moles over liters. I need to find that liters, but I have molarity, and this is what I'm looking for, and I don't know what those moles are, but I do have those grams. So let's take care of that first. I have 5 grams of potassium chloride, and I want to get rid of grams, and I want to go to moles. 1 mole is equal to the gram formula mass. So let's take our gram formula mass, right? So potassium is a mass of 39, and chlorine has a mass of 35, and so that's going to be 74 grams. So then I take that 5 divided by 74, and that's going to be our moles. So that's going to be, and I'm going to keep that to 2 significant figures, 0.0, oops, sorry for that ugly looking 0, 0.068, and that's going to be moles. Okay, so that's how many moles of potassium chloride I have. So now I can take my molarity, right? That's over here, capital letter M, right? Capital letter M. And I'm going to do my 0.25 molar solution. And now I have 0.068 moles. And now I've got my liters, right? And if you want to, we can call that X. There we go. So then I can crisscross applesauce and I can cross multiply, right? And I can do 0.25 times X is equal to 0.068 and divide by 0.25, right? To get rid of that, divide by 0.25. So I'm going to take that 0.68 and I'm going to divide by 0.25. And that's going to be equal my volume in liters. And that's going to be 0.27 liters. All right, last one. Okay, how many grams? Okay, so that means the last step I'm going to do is going to be converting from moles to grams, right? Because that means I need moles. I have 100 milliliters. First of all, that's milliliters. I need to convert that to liters. And here I have my molarity, which is my capital letter M. So we're going to start with our molarity formula, right? So molarity is equal to moles over liters. Okay. So my molarity is 0.10. And I need to find the moles before I can get those grams. My milliliters, 3 decimal places to the left, divide by 1,000, right? So then that's going to be 0.100 liters. So then I'm going to take that 0.1 molarity and I'm going to multiply that 0.1 liters. And now that means that I have 0.01 moles. Okay, now we need to go from moles to grams. 0.01 mole. And now I want to go from moles to grams, right? So getting rid of moles and going to grams. And then 1 mole is equal to the gram formula mass. I know this one off of the top of my head. This is mass, this is going to be 250, which is 250. And so now I'm just going to multiply that 0.01 times 250. And that's going to be equal to 2.5 grams, right? Because moles divided by moles. All right, how did I get that 250? Quick review. That dot does not mean multiply. That means that there are 5 moles of water attached to every one copper sulfate, right? It means it's not chemically bonded. It means it's attached. We never use a dot to multiply in chemistry. So I have the mass of copper, 64. I have the mass of sulfur, 32. And then I have the mass of 4 oxygens, each one with mass of 16. And then I have 5 water molecules, and then each water has a mass of 18 because I have 1 oxygen and 2 hydrogens. 16 plus 1 plus 1 is 18. And then that's going to be our total of 250. All right, so that completes our walkthrough, and I hope that you got some better understanding of how to work with molarity and how to also work with moles. All right, so make sure you ask myself or Mrs. Mittiga any questions that you have, or if you need help with this, feel free to watch this video again. And the more you practice, the better you get at these chemistry problems. All right, until our next